And email. Seven point 13/5. All right, here's the question. And it is a Father Time question. Now we did start with time and area under a curve, right? We started talking about that, right? I need somebody to say yes or no.
Yes, we did.
Thank you. I appreciate the interaction, much as y'all hate to do it. And I'm going to draw everything while y'all are drawing everything. 0 to 30. That's 15, 5, 10, 20, 25. Height is equal to 1 over 30. Okay, A says they want the probability that a friend is between 10 and 20 minutes late. And then B, given that 20% chance, how many minutes does that turn out to be? 20% chance. All right, so here's what it looks like after you write it down. So, can everybody see that okay? I hope everybody can. Nobody's going to say, y'all mad at me this morning or what? Y'all act like y'all mad at me or something. I know I let y'all down by being late this morning, but you don't have to take it out on me. And nobody's going to say anything. Y'all really suck. Y'all know that? I hope y'all try to carry on a conversation with somebody and they don't talk to you. I want y'all to see how it feels. Yeah, nothing. Sorry, one of these days, you're going to be paid back for this. And y'all do y'all's other classes like this too, don't you?
I have no idea what you just said. It froze.
Right. Well, it's not my fault. I done redone everything here. I had to do it before I started, so it's not my end. So is that y'all's thing now? Y'all just gonna start using the internet saying you can hear me? Is that what you're gonna say? I can't hear you, Hubert. Y'all suck. All right. So first thing I'm gonna do is I'm gonna plot 10 and 20. Right here, 10 and 20. So 10 and 20. Now somebody tell me what between means. Give me the definition of between. I'm just kidding. Hopefully y'all know the definition of between. But think about it. Try to put between the words. Oh no, Miss Poor's video. Miss Poor's had it. She says, I've had it with this class. This class sucks.
That's what my video went out?
Yeah. Do y'all see Miss Poor?
I can see her.
It was clear to me.
Okay, now that's weird. Y'all trying to drive me crazy now. Okay, I'm
gaslighting
gonna
you.
show y'all. I'm gonna show y'all right now. Look at this. Okay, now what does Miss Poor look like? So it's like a
The letter-
big O with a P on it. Do y'all see what I see? So I'm not crazy. Miss Poor's video has gone out. But y'all can see Miss Poor.
Yeah, we can see her.
Yep.
Okay, I'm done. I'm not gonna try to, y'all not gonna drive me crazy. I know that's what y'all trying to do. Y'all say y'all can see her, but y'all can't. I know what y'all are doing. All right, so here is between. So somebody tell me what the base of that rectangle is. What's the base?
10.
10. So base times height, which is equal to 10 times 1/30, which is equal to 1/3, which is equal to 0.3333. And that's how you do that. Now, what is the chance that you're going to show up? What is the minutes that apply to a 20% chance of being late? So 20% is an area. So 20% is equal to base times 1 over what? 30. And how do you get rid of multiplying by 1 over 30? I'm asking y'all a question. That means y'all need to answer it. How do you get rid of or undo multiplying by 1 over 30? You divide by 1 over 30, Hubert. That's right, class. And that means multiply by 30, the reciprocal. So B is going to be equal to, take your handy dandy calculator. And I know what 30 times 0.2 is. I know what that is, but I'm just going to show you using the calculator. And I can't believe that Miss Poor is still not showing up. Okay, that is weird. Unless y'all are lying to me, that is weird.
It might be on my end. My hotspot's not the best here at my house.
Oh, you're on hotspot?
Yes, sir. We don't have Wi-Fi at my house.
You are kidding me. You mean all this time you have been on hotspot?
Yes, sir.
Wow. That is really good. That, you know what that's called? That's called dedication. Oh my gosh. Oh my gosh. Do you know how many people would use that as an excuse? Oh, I don't have Wi-Fi here at my house. I can't get in the class. I can't see you. Thank you, Miss Poor. That's why you and your brother both are going to have real nice offices one day.
Well, thank you.
You will. All right, here we go. 0.2000 divided by parentheses 1 over 30. Now, the reason I'm doing it like this is just to show you, you can type it in your calculator just like that. You don't have to remember that you can multiply by the reciprocal. You can just type it in, and it comes out to be 6 minutes, should be. 6. So 6 minutes is equal to B. So your answers to the questions are there's a 0.33 probability. I'm going to write this up here 3 different ways because I want you to see how 0.3333 is the same whether you write it as a percent, a area, or a probability. You can put area is equal to 0.3333 and draw a line to that. You can do it like that. You can say the probability of X being between 20 and 10 is equal to 0.33 or 0.3333. And you can say there's a 33.33% chance of being 10 to 20 minutes late. Does everybody understand how percent, probability, and area can be the same thing? And that's what I told y'all before. Area, probability, and percent. They are all the same thing. Because what's going to happen is you're going to see a problem written like this. And that's the 75th percentile. So P, that's going to be 0.7500. That's an area. And we're going to get to that later. But anyway, the whole point is all 3 of these are the same thing. All right, so that's the first one. The second one is similar. I'm going to leave that up for a second. Do the Chevy Chase thing on vacation. Okay, that's right. It's not a cartoon or a... Y'all don't know what I'm talking about. Have y'all seen Kong versus... Oh, hell yeah. Everybody's seen that. Yeah. Fairy tale stuff. Everybody sees that. Anyway.
It's also new. And
There's nothing wrong with watching old movies.
Yeah, but there's a
Especially
difference
classics.
between going to the theater and watching something at home.
Oh, I love watching it at home. I don't have to deal with stupid people.
True.
And my daddy always said, stay away from yuck people. If you stay away from yuck people, life will be a whole lot better. And when you go to town, you run into 10, 20% yuck people. 80% is okay, but 10 to 20%, those are the ones that get you thrown in jail. All right, this is 7.115/6. 7.115/6. And some of y'all know exactly what I'm talking about because you work in retail or you have to work with the public, and you know that 10 to 20%, and it's growing, are people that just, you would like to take a bat upside their head. All right. Nobody going to say a word. Okay. Then I'm the only person that believes that, right? Okay. None of y'all run into people like that. It's all in my imagination. Yeah, okay. Y'all suck. 0 to 30, 15, 5, 10, 20, 25. And the height is equal to 1 over 30. It says to graph, blah, blah, blah. This is just one question. It says probability of being at least 20 minutes late. Now, somebody tell me what at least means.
Everything under is included.
Yeah, I guess you could say that. I'm thinking of a more layman's terms, what would more layman's terms be at least 20? That the lowest number is equal to what?
20.
Mm-hmm. That's what it means. So we're gonna locate 20. And then I want somebody to tell me which side are we going to shade if the lowest number is 20? The right side or the left side?
The right.
Right.
The right side. Now, a lot of people say, well, Hubert, why are you spending so much time going over that? Because people screw it up. That's why. When you see that at least or at most, students screw that up. So we want to find that green area. Y'all love my highlighters, I know. So, area is equal to base times the height. We know that our base is 10 and our height is 1/30. And that's equal to 10 over 30. And that's equal to 0.3333. Now, is it a coincidence that these two different questions are the same? That's just a coincidence. So there is a 33% chance that the person is going to show up at least 20 minutes late. Clever, Miss Gravina, clever, kind of like mine. Y'all got y'all's water bags up? Remember the water bag, the quart of water I got? Did I tell y'all about that? I got a quart of water over here on the cabinet. Looks like moonshine. And I pulled it out in front of one class. I can't remember, and everybody thought it was moonshine. It's water because of flies. You ever heard the water bag of flies? Don't forget it. Anyway, if you put up a bag of water, like a sandwich bag of water, the refraction will drive the refraction of light hitting it will drive flies crazy. They can't stand it. So if you put it near the window or, you know, where light shines on it, it'll keep the flies from being in the kitchen. It works. Anyway,
yeah, my
forget it.
kindergarten teacher did that.
Oh my gosh. So I'm not crazy. Who was that? I got to see who that was. I can't see. Who was that? Miss Yarborough. Miss Yarborough, I'm not crazy, am I?
No, it works.
It works. Everybody's going, she needs to be quiet. She don't need to be talking to him. I know. Yeah, Miss Yarborough, you need to watch it. They may get mad at you for talking to me. Thank you, though.
We do that during the summer.
Did it work?
It does.
Yep. Now they're going to talk about you, Miss Poor. Not supposed to talk to me. 0.333. Yay. Okay, now this one. Now, before, I only got a couple of these. So I'm going to have to run some off right quick while y'all are writing this one down. So hold on just a second, and I'll pull that up, and y'all can do the same thing. Let's do it together. Let's pull up our, we're going to do it together. If I could get the dadgum thing to come over here. There we go. Let's go to your file. And I'm going to do this with y'all because I know that there's 2 or 3 people. Well, no, there's probably 14 of y'all that hasn't done it. What's it called? Is it called the curve? Did I send it to y'all on this? There it is, normal distribution curve. There it is. My gosh, how did it do that? Okay, did y'all do that? What the heck? Okay, that was really weird. Did y'all see that?
Yeah, it went completely black, yeah.
Yeah. Okay, I'm getting rid of this. I'm just going to pull it up from the handy dandy documents. And it's called, what's it called? It's called the curve. What did I got so many different things. Hold on just a minute. Oh, crap. Don't do this to me. Okay, I'll just do it the old-fashioned way. I'll just do I ain't got time to look for it. So just let me do a Word document. I thought I sent it to y'all. Evidently I didn't. So insert picture. And it should be called, oh my gosh, tell me I can't find it. There it is. Normal distribution. Change this to orientation, landscape, margins. There we go. Sorry, I'm trying to do this as quick as I can. And I'm going to hit print. And I'm going to print out 10 copies. Of course, y'all could be doing this also, but, you know, that would require work, and I know some of y'all don't want to do that. So anyway, I've sent that to y'all. I don't know why I couldn't find it. But anyway, here's the question. First thing I'm going to do is I'm going to draw a picture. I'm going to draw a picture. I've got some of these colored. I wonder if I could use these. I wonder if y'all can see these. Let's see if y'all can see those. And hold on just a second. All right. Let's see if y'all can see this. There's some of mine that I colored and ran copies of. Of course, it didn't come out right because whenever I have to print out a lot, it kind of messes up. So anyway, the bottom is going to be 266. That's our mean. And then 282 and 298 and 314 and 250, 234 and 218. And that's what the curve looks like with a mean of 266 and a standard deviation of 16. Now, we haven't got into doing those problems yet. This is kind of a warm-up, a kind of a transition between 7.1 and 7.2. They're trying to get you used to doing the bottom like this, doing your base like this. This is kind of a transitional type problem. Okay? So trying to get you to think in terms of the empirical rule and the curve, all that good stuff. So they say in the problem, they say in the first part, they say that x is equal to 280 and that the area to the right is 0.1908. So that means we need to go to 280. 280 is about right here. So I'm going to draw a line at 280. And the area to the right, I'll color in yellow. And that area is 0.1908. So what does that mean? Now these are births, right? Carrying your child past or carrying a certain amount of days. Carrying X days. So somebody tell me what this means. I want somebody to put this into words. Put this yellow area into words. That means I want somebody to say something. Or say, I have no earthly idea what you're talking about, Hubert. Or tell me what I'm looking for. Which one is it? Either you don't know or you just don't want to talk. Which one is it?
Is it a 19% chance that the area to the right happens, basically?
Okay, yes. Whatever the event is, that's easy. That's a good thing to say, the event. Okay, so that's one way to say it. There is a 19.08 or 19% chance that blank, and that you will carry a child X days, 280 days. There is a 19.08% chance that you will carry more than what? 280 days. Okay, that's one way to say it. Give me another way to say it. The probability of carrying more than 280 days is 0.1908. That's good, class. Good job. Anybody want to try the third thing? Well, let's see. This says percent. This says probability. So what's the third thing? I'll give you a hint. It starts with an A.
Area.
Thank you. The area past 280 days is 0.01908. And that's the three ways to write the yellow area. Now see, they're not asking you to do 7.2 stuff. What they're asking you to do is to get ready, because instead of putting 0 right here and 1, 2, 3, -1, -2, -3, they're going to be putting big numbers down here. And that's what we're doing in 7.2, or part of 7.2. Everybody got that? Now, you do the second part. I'm going to go check my printer, because I know dang well it probably didn't print, because it never does. I want you to go check it while you're doing the second part of this problem. You got to draw it on another one of these. So go ahead and get started. No, it didn't print because, of course, one of the cartridges had to be replaced, which has to happen every other day. All right, sorry about that. I had to replace the cartridges. I have to keep 2 boxes of cartridges on hand at all times for this printer. All right, so 266, 282, 298, 314, 250, 234, and 218. Have y'all noticed something about the way I do things for the last 2 or 3 questions? This one says, where's part B? Oh, come on. I'm sorry, I didn't know. Wasn't showing you part B. I thought it was in the question. This sucks. Last more than 280 days is, this sucks, 0.1908. Okay, can you let us do the second question now? Thank you. All right, here it is. They want to know, they got the probability of 1101, 11%, between 285, so 0.1101 is between 285 and 305. Y'all heard me tell my son to water the cats a while ago. I've got one cat that plays in the water, and the floor is covered in water. All right, so here we go. There is what we're trying to find. Now, what have you noticed about every single problem I've done? What have you noticed about every single problem that I've done this morning? What do they all have in common? What do I do first?
You color it in.
I what?
You color it in with like a marker.
I draw a what? A picture.
Oh, yeah.
There are people in this room that are trying to do these problems and not draw a picture. Now, y'all don't have your videos on. How do I know that? Because there are a certain percentage of students that if I tell the sky is blue, they're going to say that the sky is red. All right? there are people that are, have y'all ever seen Bar Rescue? Y'all need to watch it. This guy has spent 35 years rescuing bars. He goes into a place that is $300,000 in debt, and the owner says, I know what I'm doing. I don't need you here. There is a fine line between stupidity and ignorance. Draw the picture. Okay? Draw the picture. I know it may be beneath some of y'all because some of y'all are so smart. That's why you're at Tri-County Tech and not at Yale. All right. I'm talking to the people that think they're so smart, not the people, not normal people. Okay? Anyway, I know there's people out there that will not draw this curve every single problem. Then don't get mad when you get every single problem wrong. All right. So 285 is where? Right about here. And 305 is probably right in here. And I'm going to color our area, color it some kind of green. All right, there's my green area. And that green area is 0.1101. Now I want somebody to just give me one of the three ways you could read that. Remember, it's carrying your baby. Carrying baby. Now, I'm not carrying your child. No, you don't want to say carrying. I don't know how you want to say it. Carrying baby. So somebody give me, layman's terms, what does the green area represent? Besides Mr. King, because the class is waiting for Mr. King to answer the question. So, Mr. King, you need to fix your hair. Your hair ain't up high this morning. Miss Gravina, can you help me out here? I know you want to be a part of, I know you want to help me out.
Can you ask the question again? Like I heard
what does the green area represent? Give me some. I mean, I got 0.1101 there, and I've got a green area, and then I've got 285 and 305 right here. Tell me what this means in layman's terms. Just.
Is it the percentage?
Yes, keep going. There's a what percentage?
Okay, so there would be a 11% percentage of the, like, how long they would carry the baby.
Okay, say it. There is an 11% chance that you will carry the baby. What?
Less than?
No, from 285 to what?
To 305.
That's it. So we're going to put that in a sentence. There is a 11.01% chance that you will carry the baby between 285 and 305 days. All right, somebody else give me another way. She used the percent. So percent is out. So that means there's probability and what? Area. So somebody put that in in the words of probability? Somebody do that. Besides Mr. King and Miss Gravina. There is a, come on, y'all can do it.
So for probability, would it be the probability of carrying a child between 285 and 305 days is 11%?
Oh gosh, Mr. Butcher, if you were here, I'd hug you. Yes, that's right. There is a 0.1101 probability that you will be between 285 and what? 305. And that's probability. And the last one is what? The area above, between what? The area between 285 and 305. Of course, you would have to put days carrying a baby, is what? 0.1101. You're welcome. So now you just go back to the handy dandy question, and now this is kind of redundant, but what they're trying to get you to see is that probability, area, and percentage is the same thing. Okay, so the proportion of pregnancies will last between 285 and 305 is what? 0.1101. And this is another way of saying it. The probability that a randomly selected pregnancy lasts between 285 and 305 is 0.1101. And that's why it's so important to draw a picture so you can actually what? You can actually see it. All right, last question. Now this one I saved the best for last because this is what your homework should be doing right now. You should be doing this in your homework. And that is 7.2 5/2. 7.2 5/2. Got 4 test questions here, and they logged me out. Don't you just love Tri-County Tech? Tri-County Brick Phone College, where we still believe in the brick phone. There we go. There's 4 questions right there. There's 4 test questions. And you're going to have to draw a picture for each one. I'm going to do 2 on each one. So I'm going to write the 2 that we're going to do. See, Z is equal to 1.65. And Z is equal to 0.01. Okay, and they say they want you to show the area to the what? The area that lies to the left of these numbers. So here's the first 2. So I want you to draw, let's do 1.65. We're going to do it in pink. We're going to do 1.65 in pink. And we're going to do 0.01 because I don't like clashes. We're going to do it in blue. So where's 1.65? Well, first I gotta fill it. Oh crap! I have to pick the pens up because if these cats grab my pens, I'll never find them again. Okay. So 0, 1, 2, 3, -1, -2, -3. So where is 1.65? Well, 1.65 here is 1.5. So 1.65 is going to be right about there. So I take my handy dandy every time I look at these highlighter colors, I think of snow cones. And I get absolutely nothing.
Snow cone does sound nice right about now.
Yeah, it does. You know you're not supposed to talk. You're supposed to be quiet. How dare you? All right, there's the pink area. Somebody tell me what this arrowhead down here is called. What is that arrowhead called? What's this arrowhead called right here? This one's called something, and this one right here is called something.
Is it unusual or something like that?
No, think of a number line. Think of the number line that you got back in third, fourth grade. What's it called? Where is that arrowhead going? Negative what?
Infinity?
Negative infinity.
Oh.
Where's this one going? Positive
Positive
infinity. But we can't put negative infinity and positive infinity in a calculator. So what are we going to use over here? Negative 9999 and positive 9999. So I want everybody to take your calculator. Well, first, let's add up our empirical rule and get an estimate. So I need somebody to get your calculator out and add up 0.15, 2.35, 13.5, 34, 34. And then let's see, 1.65 is a little bit over half. So what's half of 13.5? 6.75. So since it's a little bit over 6.75, I'm going to say 8. And I need somebody to add all those up for me. Well, 34 and 34 is 68. 68 and 2 is 70. That'd be 83. 83, 91. I'm going to say it's around 0.9200 or 92.00. What'd y'all get when you added them all up?
92.
Exactly? Wow.
Yeah.
0.9200 by the empirical rule. Now, why do I do that before I do the calculator? Why do I do this? Why do I do the empirical rule? And you can do it in your head. You don't have to write everything down and put it in a calculator. Just look. That's why you draw a picture. Add that to that. That's 2.5. That's 16. 16 and 68 is like 84. And 84 and 8 is 92. So what am I doing here? Somebody tell me why I'm doing the empirical rule in my head before I type in normal CDF.
Aren't you you trying to get like an estimate of what your answer should be?
It's kind of like a check. Yes, it's an estimate. That way, if the calculator spits out 0.12, you know something's wrong. So now let's take the calculator. Take your calculator out and do second vars normal CDF. And if you've got an older calculator, you're going to type parentheses negative 9999, comma 1.65. That's if you got an older calculator. If you got a newer calculator, second vars normal CDF negative 9999 to 1.65. And that's what it looks like in an older calculator, except you don't have the 0 and 1. Your parenthesis is right here. And hit enter. 0.9505, and that is your correct answer. 0.9505. So there is a 95.05% chance that you're less than what? 1.65. Now, I want to show y'all a trick I learned in the war. If this is 0.9505 in pink, somebody tell me what is in yellow over here. And somebody tell me what it's called. Starts with a C. O, M, P, L, E, complement.
Complementary.
And what is the complement? What makes up the whole? What's under the curve? What's under the total curve? What number?
95.
No, what's under the total curve?
Oh, 100.
1 or 100.
1.
But since we're dealing with decimals, it's 1. So what would the yellow be? One minus what?
95 or 0.9505.
9505, and that's going to be equal to what? Well, 0.0495, something like that. All right, now I want y'all to do this one. I'm going to do another curve. 0.01. I'm going to leave that on the board here just for a second. I want y'all to draw another curve, and I want you to do 0.01. So I'm going to take my handy dandy curve. And I'm going to take my blue marker. And I'm going to put 0.01 right there. And I'm going to draw a line. Now I want somebody to tell me a generalized statement from what I just drew. Somebody generalize what I'm drawing right now. Just generalize it. In other words, guesstimate what the answer is going to be, or close to. That means everybody should be answering this question. It should be pretty simple.
Close to 50.
Thank you. Why is it close? Why is it going to be a little bit over 50, right? Because it's a
Yeah.
positive 0.01. Because from your empirical rule, this right here is 50%. So by the empirical rule, 0.01 is going to give you a little bit more than 50%. And I'm not even going to do any guessing. I'm just going to say 0.5020 maybe. And that's an equal sign, squiggly equal sign with a dot over it, meaning I'm estimating it approximately. 0.5020. I'm going to say 0.5020. So now all I do, we know that this guy right here is called negative 9999. So you're going to do normal CDF, negative 99999 to what? 0.01. So let's go to our handy dandy calculator. And there's a trick I learned in the war. Second, enter, and you don't have to type all that in. So put a negative right here. I'm sorry, not a negative. I suck. 0.01. There we go. And enter. Okay, 5040. 0.505, 0.5040. 0.5040 is your answer. Now somebody right quick tell me the complement of 0.5040, and that's your yellow side. So I need somebody to take one in your calculator and subtract 0.5040 and tell me what you get.
.496.
0.4960 is your complement. All right, let's do a nerd. Now, the last two that your question says is 0.94. So I got two more copies here of my curve. I'm going to go ahead and use them up. I haven't heard my printer go off yet, so it's probably needing 5 more cartridges. It only takes 4, probably needing 5. Have you ever noticed that whenever you need something to print, it always says, "Oh, you're out of black, magenta, cayenne, and 3 other colors that we don't know about." And y'all don't say anything. Z is equal to 0.94. God, I hope y'all don't do this on dates, because if y'all do, y'all suck. Negative 0.49. We'll do that in green. Negative 0.49. Now, I want y'all, there's the two that we're doing. I want y'all to do Z is equal to 0.94 and negative 0.49. I'll be right back. I want to go get that belt today.
And, Brown, 5 or 6, Brett, I'm gonna pick you up one of
Okay, I guess I'll cut the grass.
Yay! 5 o'clock.
I did get a bunch printed. Ain't I pretty? All right. So 0.94 is right in here. So let me put my 0, 1, 2, 3, -1, -2, -3. And 0.94 is going to be right in here. Take my handy dandy. And we want to know the left side. That's what the directions say. So I'm going to take my orange highlighter. Well, that's 50. And I'm going to say, I don't think that's 34. I'm going to say 33 or 32. What's 32 plus 50? 82. So I'm going to say, I'm checking to make sure. This right here is 84, right? That's 84%. So I would say probably 82 to 83. So by the empirical rule, I'm going to say 0.82 to 0.83. That's what I'm going to say. So let's see what the handy dandy, and we know that this is what? Negative 9999. So normal CDF, negative 9999 to 0.94. Here we go. Second, enter, negative 9999 to 0.94. 0.8264. We're smart. 0.8264 is your answer. And that is the area in orange. So somebody tell me what the area in yellow is. Hopefully you're putting it in your calculator. What is the area in yellow? 0.1733. Somebody check me, please. I just did it in my head. You're welcome.
I got 0.1736.
Yeah, okay. 36. You're right. I was looking at the calculator. And this is the complement. Now, why all of a sudden have I started doing this? Because in some questions you're going to be asked, what is the right-hand side? And the way that you figure the right-hand side is you subtract the left-hand side from 1. Okay, so I'm just telling you. All right, next. Negative 0.49. And that's in verde. Como se dice verde español? Green. Y'all are impressed. I ain't no dumb country boy. I'm a Renaissance man. All right, negative 0.49. So this is 1. Je m'appelle, you belle. Parlez-vous français? 1, 2, 3. Negative 1, negative 2, negative 3. Thing old Scheistikov. All right, so negative 0.49. Here is negative what? 0.5. So negative 0.49 and it's right there. Now, let me ask y'all a question. If y'all come to me in my office or came to me virtual office hours and said, Hubert, I need you to help me do number 14. And I pull number 14 up and it says, find the area to the left of blah, 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 blah. What's the first thing I'm going to do? I'm going to draw a what? Picture. I guarantee you there's somebody out there right now in the, how many we got in here right now? In the 15 that are attending right now, there's probably about 5 or 6 of y'all that aren't drawing a picture. And y'all are the bar owners on Bar Rescue that is $250 to $100 million in debt, and you tell John Taffer that you know how to run a bar? Excuse me, if you knew how to run a bar, you wouldn't be what? In debt. Now, by the empirical rule, I think that's going to be, what's half of 34? 17, Hubert. That's right, class. So it's a little bit over 17. So I'm going to say 18. Since it's negative 0.49, it's a little bit to the right of half. So I'm going to add, make it 18 here. So that's 18 and 16. What's 18 and 16? Dang old 34. So I'm going to say it's around 34%. Okay, get out your handy dandy calculator. And second. And I'm going to go to negative 0.49. 0.3121 is your actual answer. 0.3121 is your answer. So therefore, somebody tell me what the right side would be. 0.6879.
Yeah, that's right.
And y'all just done, excuse me, y'all just done 3 plus 4. You've just done 7 test questions. Actually 8, because that one question we just did had 2 parts. The one we did a while ago, and this is 4, so that's 6, 7, 8. You've done 2 times question, 2 uniform distribution. That was a square or the rectangle. And then you've done 6 area under the curve questions. All of them are good questions. All of them are good test questions. Now, what's the difference? And I've only got like, well, I'm out of time. I want you to continue working. There's only one problem we haven't done, and that's the one that you that you have big numbers under like this. And they ask you the area between 250 and 266. And you can't put 250 and 266 in your calculator. So we've got that problem to work on Friday. No, what's today? Thursday. Okay? So keep working on 7.1 and 7.2, and we will finish 7.2 Thursday. Now, those of you that came in late, go ahead and just stand by. Those of you that I called the roll early,